Welcome to section 4.5. In this section, we're going to conclude talking about linear regression by focusing on evaluating the strength of the fit, as well as taking care in interpreting the results, and we'll look at one more example. So when we talk about the fit, we're talking really about what kind of relationship we're seeing between the two variables. In general, if there's any relationship between two variables, we'll call that an association. And then we use the word correlation specifically for a linear relationship between two variables. Since we're focusing on linear regression, we can use the two words interchangeably. But just be aware that association is broader than correlation. So how do we measure the strength of the correlation? Well, there's a couple of things we can do. The first uses something called the correlation coefficient, denoted with an R. This is a number that is between -1 and 1, and the closer you are to either -1 on one end or 1 on the other end, the stronger the correlation, whereas the closer you are to 0, the weaker the correlation. And the sign, whether it's positive or negative, tells you whether it's a positive or negative correlation, whether the relationship is increasing or decreasing. So let's see some pictures here. I apologize for my disembodied floating head covering up a little bit of this diagram. But let's see what this tells us about the correlation coefficient. So in panel A here, we have R, the correlation coefficient is -1. Notice the line is going down. This is perfect correlation. And the negative sign means as we move to the right, as the X gets larger, the Y variable gets lower. Right? And that's perfect, all in a line. As we start departing from the line, as the data points start moving away from the line, the correlation coefficient gets closer to 0. So here there's a pretty strong relationship, right? The data seems to be following a downward trend. So that would what you might see with R equals -0.8. R equals -0.4 in panel C is weaker, much weaker. Right? You see they feel a little bit scattered all over the place. There is a slight tendency, a slight decreasing tendency, but it's very weak. R equals 0, a 0 correlation coefficient means it's all over the place, no relationship one or the other. And now we increase to R equals 0.6. That's quite a bit stronger, actually. It's definitely stronger than 0.4. You can see in panel E here that there's an increasing trend. Ignore the shaded area. The shaded area is what happens if you restrict your data, and we're not going there. And R equals 0.9, you can see this is a very strong correlation, right? Very strongly increasing as we go to the right. Not a whole lot of deviation from a line. The other thing we do regarding the strength of the correlation is we look at the explanatory power of the X variable. And that comes from taking your correlation coefficient R and just squaring it, called, simply enough, the R squared. This tells you the percentage of variation in Y that's attributable to variation in X. In other words, how much does X explain what we're seeing with Y? So let's go back and take a look at these two measurements for our salary data. So here's the scatter plot we saw with our salary data. The data being over on the left. So before I show you the R and R squared, based on the last set of diagrams that I showed you for R, pause and take a guess at what range you might expect the correlation coefficient to be. Okay, hopefully you paused and thought about it a little bit. Let's see what Excel told us. So when we ran the regression in the last section, we got all of this stuff, and we just focused on finding the slope and the intercept that were estimated for the line of best fit. Now we're going to also look at these other two areas I shaded. So what we talked about in the last set of slides were what I shaded over here in green. So the correlation coefficient, they call it multiple R, and the reason they do that is because you may have more than one X value. The X values are your explanatory variables, whereas the Y value is what you're predicting, your prediction variable. And if you have multiple variables for X and X1 and X2 and X3, as you're trying to explain multiple variables that might help explain salary, might add geography, for example, location, then you'll have multiple R's, right? And so that's what that means. For us, that's called multiple regression. We're focusing on simple linear regression, meaning just a single variable. So this is our correlation coefficient is 0.97824. We can see it right there in cell F29. Very strong. So if you thought the correlation coefficient might be above 0.9, congratulations, you got it right. It's very close to 1, and it's positive. As we can see, the positive relationship, the more experience you have, the higher your salary. And it makes sense that that would be positive. And then R squared, if we square that number, we get 0.95696. So what is that? That's about 95.7%. And that tells us that 95.7 of the variation in salary is due solely to experience. That means there's a few other factors that may be at work here too. How well connected you are, where your office is located. It also there could be related variables that we don't want to be related, such as gender or race. We would hate for there to be a difference based on gender, but unfortunately it happens. And we, of course, as a society are striving to make that go away. So anyhow, those two measures tell us the strength of our correlation. There's something else here as well in blue. These are called confidence intervals. Let me explain what those are, and then we'll come back and take a look at these numbers. So what a confidence interval is it's an interval, so it's a lower and upper value that we say with 95% confidence that parameter lies between those two numbers. What that means, 95% confidence, you'll explore that a little bit more. It's a probabilistic statement. So what we're talking about here is some uncertainty based on that data, right? There's a little uncertainty as to whether or not the line that fits it best is actually the true signal. If you take a statistics course, you'll explore, especially if it involves inferential statistics, you'll explore a little bit more precisely what that means, that 95% confidence means. But basically, this is a way of handling a certain amount of uncertainty. So with 95% confidence, we think the true parameter lies between the lower and upper bounds of this interval. Typically, we're interested in the slope because the slope is telling you how, in what way the x value is driving the train. Right? So with the slope, the confidence interval tells us that with 95% confidence, we believe the slope is between the lower value and the upper value. And note, of particular interest is whether or not 0 is in that confidence interval. And the reason for that is because if the slope is 0, that means the x value has no impact on the y value. So if it's in the interval between L and U in our confidence interval for the slope, if 0 is in that interval, if you have a negative number and a positive number, then that means you can't really conclude that there's any association or correlation, no matter how well that line fits. Let's take a look at the confidence interval for this example. So for this example, the blue region is giving us our confidence interval. So this is lower 95%, that's our L for each parameter. Upper 95% is our U for each parameter. And what we're really interested in here is the slope. These are the two numbers that we're interested in. So I'm going to highlight these and let them go back to no fill. So take a look. This tells us our slope was about 9450. You can expect your confidence intervals to be symmetric about the estimate. So we think the true impact of experience on salary will be between 8674 and 10,225. And remember, that tells you how much extra in salary per year you can expect given an extra years of experience. And of note, both of these numbers are positive. 0 is not in the interval. And so we do think that there's probably some relationship between years of experience and salary. And of course, that makes sense. What kind of relationship? That's where we need to take some care. And we'll talk about that in the next video.